Hello everyone. In this video, we are going to discuss the end semester question paper, question number 6, which is divided into two parts, A and B. A part is describe how the coefficients in linear regression are estimated using either the closed form equation or gradient descent. Part B is explain logistic regression and use the logistic function to calculate the probability of a class for a given input example. So, first part is linear regression coefficient estimation. So linear regression models the relationship between input variables x and output y using line y is equals to beta 0 plus beta 1 x1 plus beta 2 x2 plus this goes on to beta n xn. The goal is to find the best coefficient that minimizes the precision error. So first is closed form solution normal equation, which is beta is equals to x power t x whole minus 1 x t y. X is the feature matrix, y is the output vector. So this gives the exact solution of minimizing residual sum of square RSS. And these pros are that it is direct and no iteration. Cons are computational, expensive for large data set. Then we see the gradient descent approach, which is w is equals to w minus alpha, which start with initial coefficients. Compute gradient of the loss function with respect to each coefficient. Update coefficient iteratively using learning rate alpha. Repeat until convergence. So this is the formula of the gradient descent method given over here. So closed form is exact but slow for big data, whereas gradient descent is iterative and scalable. Part B, logistic regression and probability estimation. Logistic regression is used for binary classification instead of predicting a numeric value. It predicts probability of a class. So logistic function, which is sigmoid, the output is between 0 and 1, representing probability. The threshold usually 0.5. This is the predicted class. It is the model and logistic function given over here step by step. Example, suppose we have beta 0 is equals to minus 1, beta 1 is equals to 0.8, x1 is equals to 2. We will compute z and then compute probability and then classification will be done here. So logistic regression transforms a linear of combination of features using the sigmoid function to output probabilities, making it suitable for classification. So in this video, I discussed question number 6 of end semester examination. Both A and B part are covered in this video. Thank you. Hello everyone. Today I am going to discuss end semester question paper, question number 7, which consists of two parts, A and B. A part is write a k-mean clustering algorithm and discuss how initial centroids influence results. B part is write a k nearest neighbors algorithm using Euclidean distance. So on starting with the part A, k-means is an unsupervised learning algorithm which is used to group similar data points into k clusters. Steps for the k-means algorithm are choose initial centroids, randomly select a k point as initial cluster centers. Then second step is assign points to nearest centroids. Compute distance, usually Euclidean, from each point to centroids. Then assign each point to the closest centroid. Then step 3, recompute centroids. That means the calculate the mean of all points in the each cluster to update the centroid. Step 4 is repeat steps 2 and 3, which is continue until centroids do not change or max iterations reach. The final step is step 5, output final clusters. And the effects of initial centroids are poor initialization can lead to slow convergence, suboptimal clusters, which is local minima, and the solution for this is use k-means plus plus or run multiple times and select the best results. K-means is a simple but sensitive to initial centroids. Smart initialization improves clustering quality. So as discussed, k-means clustering algorithm and initial centroid influence results. Part A is discussed over here. Then part B, which is k nearest neighbor algorithm using Euclidean distance. KNN is a supervised learning algorithm which is used for classification or regression. It predicts the class of a point based on its k nearest neighbors. For Step for KNN algorithms are: first step is choose K. When we select the numbers of neighbors to consider and then compute distance for a new point, like calculate the distance to all training points in the Euclidean distance formula is given over here, and the select K nearest neighbors, which is step 3, in which pick the K points with smallest distances. And step 4, vote or average, which is comes in the classification, which is majority class among neighbors, and the regression, which is average of neighbor values. Then fifth is assign prediction. Assign the predicted class or value to the new point. So KNN is simple, intuitive and non-parametric, but runtime increases with data set size and feature scaling is important. So in this video, we covered question number 7 of end semester examination. Both A and B part are covered in this video. Thank you. Hello everyone. Today in this video, we will understand the question number 8 of end semester examination, which is divided into two parts. Part A, compare decision trees, random forest and boosting, highlighting strengths and weakness of each. Part B is explain the architecture and components of Hadoop, HDFS, Yarn, MapReduce, or describe Spark and its advantages over MapReduce. This is the question number 8 of end semester examination. Let's discuss part A. Let's compare decision trees, random forest and boosting in terms of their strengths and weaknesses. First is decision tree, which is easy to understand and interprets, handles both numerical and categorical data. Non-linear relationships captured. Weaknesses are prone to overfitting, sensitive to small changes in data, can have high variance. So decision trees are simple but may overfit if the tree grows too deep. Random forest. Random forest strengths are reduced overfitting by averaging multiple trees, and it handles large data sets well, and it can estimate feature importance. Weakness is harder to interpret than a single tree, slower to train compared to a single tree. It requires more memory, and random forest use multiple decision tree to improve stability and accuracy. Third is boosting, which is example AdaBoost and XGBoost. For strengths, it has focuses on misclassified examples to improve accuracy, and it has strong performance on many datasets. It reduces bias and variance. Weakness of boosting are sensitive to noisy data and outliers. It is slower to train because sequential approach, and it is harder to interpret. Boosting is powerful, but it can overfit if the data has noise. So this, as it is given over here, that decision trees, random forest, boosting, all differences given on the basis of aspect. So decision trees are simple, random forest reduce variance, and boosting improves accuracy but may be complex. Now let us understand the part B, which is Hadoop architecture and components, which contains HDFS, Yarn and MapReduce. First, Hadoop architecture. HDFS means first is HDFS, Hadoop Distributed File System, and it stores data across multiple nodes. It has fault tolerance and high throughput. Second is MapReduce, which is processing framework, in which map phase is there, which means process data into key value pairs, and it reduce phase, which has aggregate results. Yarn, which is yet another resource negotiator, which is resource manager. It schedules and monitors application across clusters. So we discussed all the Hadoop architecture components: HDFS, MapReduce and Yarn. So then after that, we see Spark and its advantages over MapReduce. So in memory processing, it is faster than MapReduce. It uses resilient distributed datasets, which is RDDs, and it supports batch and real-time sharing, real-time streaming. It has flexible APIs such as Python, Java, Scala, and R language. The key advantages over MapReduce are: it is much faster due to in-memory computation, and it supports iterative algorithms like ML efficiently, machine learning. And as third advantage of MapReduce can be easier programming model. And lastly, it combines batch, interactive and streaming in one framework. So Hadoop provides reliable storage and batch processing, while Spark improves speed and flexibility within memory processing. And advanced analytics. So in this video, we discussed the question number 8 of end semester examination, which contains both the A and B part. I have discussed both the A and B part in this video. Thank you. Hello everyone. Today I am going to explain the question number 9 end semester examination. It contains two parts, part A and part B. Part A is obtain basic logic gates from neural networks, summarize them in table with number of neurons, activation functions and backpropagation in neural networks. So part A, here neural networks are the mimic the neural networks are which mimic the behavior of basic logic gates like and, or, and not. So here's how each logic gate can be implemented using a simple neural network with inputs representing binary signals, zeros or ones, and neurons acting as processing units and an activation function like the step function. So here is the activation function uh, with logic gates and or not an XOR with number of neurons and backpropagation used. So AND gate logic gate used number of neurons 1, and the activation function is step function, and backpropagation used here is no, because weights can be hand calculated. And OR gate number of neurons is 1, step function and backpropagation used is no. And NOT gate number of neurons same as AND and OR gate 1 as the step function, and backpropagation here is used no. XOR gate has two number of neurons with hidden layer plus one output. So activation function is step or sigmoid, and backpropagation used here is yes, because it required to learn weights for non-linear reparability. Notice that AND, OR and NOT can be done with a single neuron, while XOR requires at least one hidden layer and learning through backpropagation because it is non-linearly separable. So we discussed here the part A. Now for the part B, we will compare some popular neural networks types. As the question is comparison of advanced neural network architectures, in which it is CNN's convolutional neural networks and RNN's recurrent neural networks, GAN generative adversarial networks, and transfer learning. So in CNN's computational layers, pooling layers, and fully connected layers are there, and its application and use cases are image recognition, object detection, facial recognition. RNNs are recurrent connections, hidden states. The main components are it is hidden states, and it is used in time series prediction, language modeling, and speak recognition. And GAN, which is generative adversarial network, its key component is to generator plus discriminator and adversarial setup, and its application are image or video generation and data augmentation and deepfake creation. And the last, transfer learning. In this way, the key component is pre-trained model plus fine tuning on new task, and its use cases are small data sets, medical imaging, NLP tasks like sentiment analysis. In short, CNNs excel at spatial data, RNNs handle sequential data, and GNs create realistic data. And transfer learning leverages pre-trained models for faster, efficient learning on new tasks. So in short, neural networks can replicate logic gates. Simple ones don't need training. Complex ones like XOR require backpropagation, and different architecture have specialized strength like CNN images, RNN sequence, GN data generation, and transfer learning reuse knowledge. So understanding these basics help us build more complex AI system efficiently. And in this video, I discussed question number 9 of end semester examination. Both part A and B are discussed in this video. Thank you.